All right, in this last video for the course, we're going to talk a little bit about the three fundamental principles that we've worked with over the whole semester. Now, it might not be clear to you yet, but we've only worked with three big ideas in this course. So, what we've been talking about are this concept of a system. So, a physical system that interacts with its surroundings in some way. And what we have now are descriptions, ways of understanding how that system is going to change various properties based on influences to the system. So for example, an object or a system might experience a force. And if that system experiences a force, it's going to respond by changing its momentum. A system might also experience, that's a terrible arrow, a work, or an exchange of energy due to a temperature difference. That will change the energy of that system. The final thing is it could experience a torque. And if it experiences a torque, it'll change its angular momentum. So these three properties can characterize most of the systems that we have in mechanics. And the influences to those, whether they be forces, works and thermal exchanges, or torques, give you specific responses by the system. That is, if you're looking at how the momentum of a system will change, it has to do it in response to an external force exerted over some amount of time. If you look at how the energy of a system changes, it has to do it in response to some work by the surroundings or some exchange of thermal energy due to a temperature difference. And finally, if you're looking at how the angular momentum of a system changes, it does so in response to external torques exerted over some amount of time. So these are the fundamental principles of mechanics. They can help us describe and explain all kinds of motion, and used together, they're very, very powerful. But one thing that is very interesting about these, they're empirical. They're things that we observe and we understand to be physical truth in some sense because they have been tested over and over and over again. But if you were to choose a system that is the universe, where everything is inside of your system, right? Everything that we talk about is inside of the system. There are no external quantities here. The universe does not change its momentum. It doesn't change its energy. And it doesn't change its angular momentum. These are all quantities which the universe has, and they seem to be conserved. And we don't understand why exactly. So there's some beginning to the universe which set these quantities, and now it exists that way. And if that really doesn't bother you, maybe it should. Maybe you should try to understand this some more and try to figure out how this is going to work or why this works. What we understand right now is that the quantities that we have for the momentum, energy, and angular momentum of the universe are static. They're not changing. We look around and that's what we find. So these core principles of mechanics are very fundamental, but also deal with very deep issues regarding our universe.